to understand, some basic vocabulary so that we can use it as we talk about the properties of a circle. Okay, so I'm going to start out with the first one, and that's a circle. If you were to define what a circle was, what would you come up with? So remember, we're on page 7. Okay, keep going. That was just our checklist. Okay, so if you were to define what a circle is, what's a circle? What do you got?
It's like a 2D sphere.
2D sphere, okay, because a sphere is 3D, okay, all right. But what makes it a sphere then?
It's circle.
Okay, all right, what do you got?
It has no vertices.
Has no vertices, okay. No sides, no corners or vertices. Anybody else? Okay, those are all good. All right, and simply put, it's going to be a set of all points that are equidistant from a given point. Okay, so when I use the word equidistant, what does that mean? What's equidistant? Same distance. So they're all the same distance from a given point. What would that one given point be? What's special about a circle? There's a particular point in a circle. Anybody know? Well, how about they're all the same distance away from the center of the circle, okay? So if we were to start out, okay, we just draw a circle. Okay, we're going to put a point inside that circle, okay, and that's going to be our center. And we'll start with A. How about that? Okay? So one of the first things that you have to understand is symbols. Okay, so if you ever see the symbol, a dot with a circle and then A, what they're saying is circle with center at A. It's similar to like when they say triangle ABC, or if they say, polygon ABCD, all right? It's just their way of, labeling or naming the circle, okay? So just so you understand what that is, all right? So circle A, again, a circle is a set of points equidistant from a given point. Okay, and that given point is the center. All right? So they're all the same distance away. Now, what is that distance called? So if I were to choose, a point here, and I'll choose this point B, what is this distance called? That's called the radius. Okay, so as I go through this, I'll, put symbols down here too. So AB, okay, with a line over it, so line segment AB, okay, is a radius, and that's the distance from center to a point on the circle. All right, I'm going to choose another point. I'm going to make it C, okay, and this is also going to be on the circle, okay, and I'm going to draw a line from B to C, okay. BC is a chord, okay, so if I said BC, I'm going to put a line above it, okay. Now a chord is a segment, and I'm going to emphasize that it is a segment with endpoints on the circle. Okay? Can someone tell me, if you think about this, what would be the longest chord that you can come up with in a circle? What's the longest chord? Like, for example, if I were to go on one side of the BC, okay, I could get this chord, okay, but it looks like it's smaller. Okay, and if I go all the way to the other side of the circle, this doesn't look very big at all. So what's the longest chord in a circle? The diameter. So the diameter is a chord. It passes through the center. That's the only difference for it. Okay, so the diameter is a line that passes through the center, or we could say a chord that passes through a center. Okay, and if I were to put, letters to go with this, it looks like we're on D and E. Okay, so DE. All right, so it is the longest chord, okay, must pass through center. Okay, so through the center of the circle. All right, secant. Now, I'm going to go back to my BC when I do this, and I'm going to do it on purpose. And that is, I'm going to put BC, but this time I'm going to put arrows above it. Okay, so a secant is this line here. Okay, so here's BC, but it extends through the circle. Okay, so a secant is a line that passes through the circle. Okay, and the big thing that I want to emphasize is notice the difference between chord and secant. You're going to have to make sure you understand the difference between those two things. Okay, number one, a chord is a segment, whereas a secant is a line. Okay, so understand too, I used BC for both on purpose. Okay, notice the symbols are different, okay, as well as the definitions are different. Okay, so chord ends at the circle, a secant just passes through and keeps going. And remember, a line just goes on for infinity. All right? And then lastly, we have a tangent. A tangent, I'll go with this one. I'll have it touch at C. So I'm going to do this. It's going to touch the circle at C and then just keep going. Okay? And if I were to put another point on this line, I'll make it F. Okay? So if we have FC, okay? All right, so FC is our tangent. It is a line that touches the circle. Okay, and the big thing that we are going to talk about today with this is that if I were to draw the radius AC and it were to meet at the same point, that tangent point, C is known as the point of tangency because that's where it touches. Okay, it is going to form a right angle, and that's going to be one of the big things that we're going to talk about today. All right, so that's going to be one of our properties as we get to it later on. All right. Questions so far? All right, so then try example 1 on your own. Emily, what'd you get for AC? Radius. Julie, what'd you get for AB? Diameter. Who's got DE? Notice it has the arrows. DE, you got tangent. That is correct. Okay. And then make sure you understand point of tangency would be B. That's where it touches the circle. And then what's AE with the arrows?
Secant.
That's a secant. Okay. Questions on those? So that's one of the keys for today. You got to be able to understand your vocab and identify different things. All right, so then we go on to radius of a circle. So remember, the radius of a circle is simply your distance from the center out to the circle. So what's our radius for circle A? 3. Okay, the diameter goes from one side of the circle all the way across. Okay, what's the diameter? 6. What are we supposed to notice about the diameter compared to the radius? It's always double. Okay, so what's the radius of B? 2. So I don't even have to count my squares for the diameter. I should just double it and I should get 4. Okay, and it works. Questions there? All right. All right, points of intersection. If you were to imagine two circles that were trying to intersect, how many times could two circles intersect? Could they intersect 5 times? 2 circles? 3 times? 4 times? You said they could intersect 2 times? All right, so he says, is that the most? 2? He's thinking about it. What do you guys think? Can it intersect more than 2 times? What, Matt?
What if like 2 circles are on top of each other?
Okay, you mean like literally the same radius length
Yeah.
and everything?
Or like to the side.
I guess that would be like an infinite set of points. But let's talk about this idea, okay? So if I were to have this circle intersect this circle, how many times do they intersect? Twice. Okay, so the question is, can that happen more than twice? Is it possible to draw two circles and have them intersect more than twice? No. Okay, so two's the most. So then from there, unless we do like Matt said, and one's on top of the other. All right, so how would it be possible then for them to only intersect once? Yeah.
Just the tips are touching?
Okay, so it'd be like, kind of like drawing the figure eight or the infinity symbol. Okay, they're just touching. All right, so they have one point of intersection. All right, and then none. Well, no points of intersection is obvious. It could just simply be like this. But then one of the things that I want you to be aware of is this situation. Okay? This is where they have the same center. These are going to be called concentric circles. Okay? And concentric circles have the same center. All right? And notice that they don't intersect at all. All right? It's similar to like what Matt was saying, but he would say they would have the same radius and then they would constantly be touching. Okay? All right, so what we're going to do with that information there is we're going to talk about the idea of a common tangent. A common tangent, simply put, is a tangent line that is tangent to two circles. Okay? There's something known as an internal versus an external tangent. So if I were to draw two circles, okay, they don't have to be the same size, they could be. And if I start by connecting their two centers, okay, so I have my two center points, and I connect them with a line. An internal tangent would pass between the two circles. It'd be tangent to both, but it would cross this blue line. Okay, so this is an internal tangent. It's tangent once over here, it's tangent once over here. Okay, what makes it common is it's tangent to both. Internal means it's going in between the two red circles or it's crossing that blue line. Okay, so this is an internal common tangent. Whereas an external common tangent would go from one circle to the other circle and not cross that blue line. So it would look like this. Okay, so it's going basically kind of like on the outside of the two circles. This would be your external common tangent. All right, so the idea on examples 3, 4, and 5, what you see here is to see if you can draw an internal and an external tangent for each one of those figures. It may not be possible to draw both, just FYI. Good. Okay, I see like, you know, on this one, you got your external tangent here, okay, and then some people are just drawing your, whoops, I shouldn't have it touch, okay, or I just simply touch and then touch. All right, so then you've got your internal tangent here, okay, and some of you are even drawing the line from center to center, okay, showing that it intersects. All right, so on the middle one, some people said there's not a way to draw an internal tangent. Is it possible to have an internal tangent on the second one? So did anybody do an internal tangent like this? Is it touching both circles at one point? Sure is. Okay, so there's your internal tangent. Okay, would it be crossing the line that goes from center to center? Yes, it sure is. Okay, so it is possible to have an internal. Okay, and then it is still possible to have an external. Okay, it goes from one circle to another. Okay, all right. Third one, is it possible to have an internal on this one? No, because if you try, then it becomes this. Okay, and it goes through the circle. What's that line called? Secant. Okay, which is not a tangent. All right, so there's no internal possible on this one, but you can still draw an external. It can still touch both, okay? All right, so make sure you understand that. All right, the theorem that you see down at the bottom, we already kind of talked about this. I put this under the definition of a tangent. A line is tangent to a circle if and only if it is perpendicular to a radius of the circle at the point of tangency. So If you see this right angle here, okay, that tells us that it is tangent, okay, at P. Okay, it's forming a right angle between the radius, QP, and then line M, the tangent, right? Okay, so one of our properties of a tangent. Page, okay, the question here, it's starting out with the idea, is ST a tangent line? So what they want to know is this a right angle? Yes or no? How can we determine that? How can we determine if that's a right angle or not? Who said it? Pythagorean theorem? How did the Pythagorean theorem help us?
If it ends up being equal to each other, like two legs to hypotenuse,
Mhm.
equal to each other,
Okay, and what if they're not equal to each other?
then it's not.
Very simple, okay? So she says if a squared plus b squared equals c squared, it's a right triangle. If a squared plus b squared doesn't equal c squared, it's not a right triangle. Okay, which one has to be the c? 37, the biggest number, right? So try it, see what you get. If I were to do 37 squared, what do I get? 1369, 1369, and then 12 squared plus 35 squared is also 1369. Okay, so if they are the same, then that means that yes, that ST is a tangent line, okay? If it hadn't worked out, then it would not have been tangent, okay? All right, so in example 7, they're telling us that B is the point of tangency. So they're telling us that AB is tangent, which means that this is a right angle. We don't have to determine it, we basically already know, okay, based upon our properties. All right, so the idea is to find the value of R. And this is what we're going to do. We're going to do the Pythagorean theorem, okay? The only difference is we have to possibly do some foiling, maybe some factoring, maybe just some solving, we'll see. All right, so when I go to do my Pythagorean theorem, if R here represents my A, I got R squared. If 80 represents my B, I got 80 squared, okay? And then my C, understand that the 50 is the outside part, R is the inside part, which means together it's R plus 50. That represents my C. So I have to do R plus 50 squared. Okay, and this is why we talked about the factoring and all that stuff before we went on break. Okay, so what do I have to do with this R plus 50 quantity squared? I have to distribute. I have to FOIL this. So remember we said the 2 means write it twice. Okay, FOIL this. So now I get R squared from the first terms. Outside gives me 50R, inside gives me 50R, which adds up to 100R. And then 50 times 50 is 5 times 5 with 2 zeros, so plus 2,500. Okay? And then R squared plus 80 squared is 8 times 8 with 2 zeros, so 6,400. When I go to solve this, the nice thing is, I go to subtract R squared, gone. Go to subtract R squared, gone. Okay, so I don't have to worry about factoring in this case. All right? So I can just simply solve by subtracting my 2,500. 6,400 minus 2,500 is 3,900, equal to 100R. Divide by my 100, and R is equal to 39. Okay? All right, so try the next one on your own. It's very, very to the next page. Okay, so make sure you're able to do that. All right, another theorem. Last thing that we're going to talk about. Okay, and this basically talks about the idea of that we have two tangents. Okay, our two tangents here are RS is tangent. Okay, the point of tangency is R. TS is tangent. Our point of tangency is T. If you have two tangents that meet at an external point, okay, your external point in this case is S, then they are equal to each other, or they are congruent to each other. Okay, and there's a reason why. It goes back to, chapter 4, proving triangles that are congruent. Okay, if I were to draw PS, okay, and then draw RP and PT, okay, well, we just learned that tangent lines form right angles. Can someone give me two congruent side lengths of these two triangles? What's congruent? Well, that's what we're gonna try and prove. So we can't say RS and ST yet. Give me congruent parts.
Numbers?
Well, we don't have any numbers yet. What? PR is congruent to PT because they're both the radii of the same circle, right? Okay, all the radii of a circle are congruent to each other. All right, we need something else that's congruent. What else is congruent? PS to PS because of what property? Reflexive, right? Okay, so now our two triangles here are congruent by what property? Or what theorem? Do you remember? Not side, 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 because we don't have the third set of sides congruent, because that's what we're trying to prove. Well, remember that there was no such thing as ASS. Instead of ASS, it's called? No, it's not side angle side. How about HL, hypotenuse leg? So the two triangles are congruent by HL, and then therefore TS is going to be congruent to RS by CPCTC. So we just proved that. Big idea that you just need to know, the two tangents are equal to each other, okay? So in example 8, if I wanted to solve for x, what would I do? Set them equal to each other. 3x plus 4 equals 28. Subtract your 4, subtract your 4. 3x is equal to 24. Divide by 3, and x is equal to 8. Okay? So I was just trying to show you why it is the way it is, okay? But you can see all you have to do is just set them equal to each other, okay? All right, so we covered, okay? Identifying parts of a circle, so make sure you know what a tangent, a secant, a common internal tangent, a radius, a chord, all those things are. We talked about internal versus external. We talked about determining the length of a tangent of a circle, whether it is using the Pythagorean theorem or using the theorem that we just talked about. Okay, and then finding radius lengths, etc., we talked about as well. Okay?